First of all, I'm going to split the class into two groups. One group will attend the first section of the exercise lab. Second group will attend the second section. So section will be 12, 1, 30, 2, 2:45 p.m. Second section, 3 p.m. to 4:15 p.m. Okay. First, undergraduate students should attend the first section. Okay. Right now I have total 42 students, so it's roughly 21 by 21. First, I'd like to check whether anyone who have the classes after this, please raise your hand. So I will assign you for a first section first. Okay. Last name?
N-O-I, Noi.
N-O-I, okay, so you are in the first section. And
W-A-N-G.
W-A-N-G, Q1, so you are in the first section. Yes.
A-L-Q.
A-L-Q. Q. Ibrahim?
No, Raja, R-A-J-A.
A-L-Q, Raja.
Yep.
Okay, so you...
Y-A-N-G.
Y?
A-N-G, Yang.
Yeah.
Yahweh Yang.
Okay. Anyone else who has class? Yes.
J-U-N-J-I.
J. Last name?
Zhang.
J-U-N-J-I.
Zhang.
First.
Last name.
Last name Zhang. C-H-A-N-G.
C-H-A-N-G. I do
Yeah.
not have your name. Chen. I have Chen. Yan Chen.
No.
No.
Zhang. Z-N.
Z-A-N-G. John G. John. Okay. A-K-A-R-A-T-U. Okay, so you are Saras Chandra. Anyone else?
C-H-I.
C.
C-Z.
C.
Last name is
Last name.
L-I.
L-I. Siyun. Ji-Yuan.
Yes.
Please raise your hand who have the class after this. Okay. Yes. M-A-D-I. W-U. Last name?
Yeah.
W. I have only one. Begins with W.
W-U.
W-U. I do not have your name. So your last name? No, I do not have your name here. Anyone else? Yes.
W-A-N-G.
W-A-N-G is her name.
My last name is Zhang.
Yeah, last name.
My first name is Huapeng.
Last name, please.
Last name Wang. W-A-N-G.
W-A-N-G. Hui Wang. Hui Wang is her name.
Huapeng Wang.
H.
Are you undergraduate student?
Yeah.
Undergraduate student automatically the first section.
Okay.
Yes. Last name. Spell out. A-L. A-L-S. No. A-L-S. Yes. Hatem. Fazia. Fazia. Pfizer. Oh, yes.
How will be the first section?
So do you have a class after this?
No.
No. Please raise your hand who have the class after this.
Yeah.
Your last name?
Last name is B. YIN.
Y. Wei Yang.
I already sang.
Last name?
In. YIN.
In. Anyone else? Last name?
الجهني
Please be quiet.
الجهني
Spell out.
ALJOH
A-L-J.
ALJ
Manner.
منع
Okay, so I'm going to assign the other Abdallah. So you are the first section, and Bharat Kumar, Adapar, Bharat Kumar Adapar, no, Riyad, Abalawi, Riyad. Who is Riyad? Okay, you are the first section. Bender, you are first. Sad, Albogami, no. Sultan, Albogami. Dema.
Yes, I have a class.
So you are the first section. Aris, you are the first. Ibrahim, Faisal Al-Khaldi, you are the first. Okay, the 23. So the students who are going to be called from now on will be automatically the second section. Barak, so you are the second. It will be 3 o'clock to 4:15 on Thursday. Saad, Sultan, Aris, not Aris, sorry, Ibrahim.
Yes.
You are the second section. Wafa, Hatem, Abdulrahman, Hao, Yufeng, Yan, Bang Ying.
I have class after the 2:45. So
You have class 3 o'clock.
Yeah.
I have no room from now on. Okay. Yan, Chen, Yufeng Hao, Hao Bao, Abdulrahman,
Yes.
Abubakar, Fadil, Tiang Shu Gao, Chu Li, Jiun Li, Hangyun Liu. Jiun Li is the first section. Hangyun Liu, Didier, Lei Ning, Zibo, Chu. Do not come to front. I do not collect your assignment here. Beixiang. And this student will be the second section, and all the other will be the first section. Also, I'm going to post your assignment on the class website as soon as possible. So we have only the 24 computer in the class, in the lab. So even though you come to earlier, there is no space. Okay. So please come to the assigned the time, the room on Thursday. Okay. And I'm going to collect your assignment after class. Okay. So today we are going to finish the ER modeling as well as the ER modeling. ER modeling is basically consists of the entity and relationship. So just it's not the computer science concept anything. Just think about when you build your concept of the entire world or the real life world. First, you need to catch something important that characterizes something that is actually entity. For example, I'd like to keep track of the student information. You need to characterize, model the student information. How can you do that? By collecting the entities. It's a real data. So I have the student A, student P, student D, C, and so on. Then by analyzing this group of students, you may realize all of these are students and then described by something important information such as the student name, student ID, address, and major. Those will be the set of attributes of that entity. Also, you can utilize the information about the relationship between two entities. That is the reason our modeling concept is called as the entity relationship modeling. So using that entity relationship model, you can get close. Our goal is from here. It's a real life information, but it's good for human being, but it's not good for computer. Computer cannot understand what I understand, what you understand. We need to change something. Something means structured data. We need to make something data structure. So he is a computer and I'm a human being. But to manage this information using his computing power, we need to get close to that computer. How can we do that? We need to organize and eventually make something data structure. So we actually step forward, just one step from the information which is not organized yet to the computer. Okay, that is the EER diagram. Using what? Entity and relationship concept. However, that's not enough. Sometimes we have the object-oriented concept in our real life, such as super and subclasses, which cannot be described by using only the entity and relationship. So we need to extend a little bit more, that is enhanced or extended ER modeling, which is called EER modeling, in short. Okay, this is one of the examples of the ER modeling for employee. How many entities in this diagram? Four?
One.
It's one. For what? One for employee. It's an employee entity, just one entity. Okay, so nothing but the employee. But using ER modeling, we cannot represent this complicated relationship. In other words, super and subclasses, or generalization and specialization relationship, we cannot represent such a complicated relationship using only ER modeling. So we need to extend that. Okay? At that time, we can consider two things. Whether this is disjoint or overlap. In other words, whether you allow overlap the subclasses, the membership or not. Another thing is whether employee will be participating in one of these. If you allow something non-subclasses, which means the employee is in the here, which is not secretary, which is not technician, which is not the engineer. It's a full or partial participant. Okay? So this is a super and subclass. Just as you have learned in the object-oriented concept, it's inheritance. So in other words, all secretary, technician, engineers, or subclasses will inherit the information about superclass employee. Why? Secretary belongs to the employee. Technician is also part of employee. Also engineer is the employee. So it has the name, social security number, birth date, address, and job title, and so on. And so engineering does. Okay, this is a super and subclasses. So EER modeling. Okay, so we can consider this to extend the conceptual modeling. This is another example for what? It's a part. How many entity can you find here? So one entity. How many relationship can you find in this diagram? There is no relationship. Okay, relationship is between two or more entities. But here, this is we make the details of part entity only. Okay, so it consists of two subclasses: manufactured part and purchased part. At that time, I have a question. So, is there any part that is also manufactured as well as purchased here? Yes or no? Yes. Wow. It's the overlap, which means there might be some part that is manufactured part. So, for example, I have the brake pad. Brake pad is manufactured. Also, I purchased, because I do not have that brake pad, I purchased from other the part shop, like the AutoZone. So it's a purchased part and manufactured part. But it's nothing but part. Okay? It's a one entity. Then, another question is there any part that is not manufactured, that is not purchased? Yes or no?
Yes.
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 In other words, that is nothing, just a part. It's not manufactured, it's not purchased. No. Because it's a full participation, mandatory. Which means each of entity, each of part should be one or more subclasses. Because it allows overlap. Do you understand the meaning of EER? So, to understand, so when I give any EER or EER diagram, you should understand what's the meaning of what information you are going to build and model here. Okay? So this is the EER modeling. More details. So far we have discussed about something pattern and after this, it's a pattern, superclass, and subclasses. So this is a super and subclasses relation, extended, enhanced EER diagram. However, at this time, how many superclass for each subclass? For the subclasses, how many patterns? Only one. How many patterns? One. In case there is only one single pattern, it's called a hierarchy. Okay? It's a hierarchy, like a family tree. Okay, how many parents do you have? It's one parent, like the hierarchy. On the other hand, if you allow multiple superclass, sometimes you have multiple inheritance. That is called lattice. Multiple inheritance. Let's take a look at this example. So, why don't you take a look at the only employee? By the way, how many super and subclasses can you find in this EER diagram? How many super and subclasses group? How many groups can you find? 2? 3? How many entity here? One. Just one. For what? Employee, right? This is nothing but employee, but it's more detailed. Then how many? This is definitely EER concept. How many super and subclasses group can you find? 1, 2, 3. First, you can easily recognize employee and secretary, technician, and engineer. This is one group, right?
Yes.
Super and subclasses. Can you find another? Yes. Employee, salary, employee, hourly employee. This is the second group, right? We have 2. Anything else? Employee and manager. This is 3. How many subclass in this year? Only one subclass. For superclass is employee, subclass is manager. Okay? At this time, probably designer, those who designed this EER diagram realized we don't need non-manager subclass. So it's only manager. Anything else? Engineer, manager. Actually, this is not the relationship. If that is the relationship, we should find the diamond, right? But we cannot. That means this is the super and subclass. In other words, even subclass can be superclass. I'm a child of my parents. Definitely, I'm the parents of my child. It's a hierarchy. It's an inheritance. So, this is also possible. Inheritance of inheritance. So, this is one group of super and subclasses. However, the difference between this one and this one is what? How many inheritance here? One inheritance from employee. How many inheritance? 3 inheritance. One is from engineer, another one is the manager, another one is salaried employee is the engineering underbar manager subclass. What can be the key attribute of this one? Go back. So key of employee will be the key of this. And also, it will have all the attribute of this one, and engineer, manager, and salaried employee will be automatically inherited. Okay? So we can find 1, 2, 3, 4 group of the super and subclasses. Also, at this time, if we allow the multiple inheritance, that is called lattice. Okay? 1, 2, 3 groups are called as just a hierarchy. But if you allow such a multiple inheritance, that is called the lattice. Lattice is the more generous than the hierarchy. This is the example of the EER diagram. How many entities can you find here? One. For what? It's a person. It's a person entity. In other words, if you are using just the ER diagram, ER concept to model the university database for a person, you cannot make this kind of the model. Instead, you should define what? Entity separately. Then what's the problem? What can be the problem? If you are not going to use the ER concept, just to use the ER concept, which means I have a person, I have an employee, I have alumnus, I have the student, and so on. What's the problem?
They have a lot of same attributes.
Yes, same attribute means
Redundancy.
redundancy.
Yeah.
Database guys really hate such a redundant information. Why? Any database, even though you are not going to use the DBMS, like you are using just the memory-based variable to manage the data. Even at that time, you don't like such a redundant information. Why?
If we want to update one thing and others didn't update,
Yes.
they will make
In other words, very hard to manage. Okay? You need to keep track of all the changes. Like this one, faculty. Faculty is also person information, it's also employee information. You need to update all of this. Very hard. Another one is waste of space. Okay? Because you should have the same information as this one. Name, SSN sex, address, and birth date over here, or everywhere. It's a duplicated information, right? So that is a reason database management, not only for the database any managing data, you should avoid such a redundant information. So using the ER model, you can avoid, not 100%, but you can do the best, such as removing the redundant information. Okay, anyway, this is one entity for person. Okay, is it the hierarchy or letters? In other words, can you find any multiple inheritance? Which one? Student assistant has two inheritance from employee and student. So this is not a hierarchy. This is the letters, the structure. Okay. You should be able to understand the meaning of this EER diagram. For example, person. There are three different types of person in the university database: employee, alumnus, and student. They can be overlapped. In other words, there are employees as well as alumnus. Yes, after you graduate, you got the job offer from the University of Bridgeport. At that time, you are the alumnus as well as the employee. Also, as an employee, you can register the course as a student. So even you can be all of three the subclasses. What else? This one, employee, there are also there are faculty, there are student faculty. That also student is from student. That is the reason, like the G8 is the employee as well as a student. That's the reason it's a multiple inheritance. This one means, double line means, all employees should be one of these. One or more? No. So disjoint. Disjoint means so clearly. There's no overlap. One of these. This one means one of these. What does that mean? This one is a single line. This one is double line. This is one super and subclasses. This one is another super and subclass. It's a separate inheritance. Okay? Don't pay attention too much the direction of cup or cap. It's the direction of the process, how you can define this one. For example, first you have the research information and teaching assistance information, then you can generalize into the student assistant. Mostly in this, the EER model is based on generalization from bottom to top. But that's not important in terms of the database model. Okay? But you can understand how we can build this kind of the diagram. So this is the let us see example for university database. So another one in the EER model is the union time. It's a little bit complicated. Let's take a look at the example. Can you find any entity here? Entity is owner and register the vehicle. They are entity, right? So, and also we have the relationship that is owns. Then, what about the person, bank, company? What are these? Which one is the, it looks like the EER model, right? Yes, it's the EER model. So, but it's not the relation. It's not the entity separate from, it's the owner. Person is the owner, bank is the owner, company is the owner, right? Then, so it's a super and subclasses. Which one is a superclass and which one is a subclass? Here, owner is the subclass. And there are three superclasses. Okay? It's all of them are owner, but they inherit their own. Right? Each one has the key attribute. Okay? If owner is the superclass, it should inherit to this way. But here, person inherit their attribute to the owner. Bank inherit their attribute to the owner. Company inherit their information to the owner. In other words, owner have three different categories. Okay? So, for example, when you purchase a car, I purchased a car recently, and with the finance, that means I'm the sole owner? No. The bank is the another owner. Actually, bank has the title. Even I never seen the title of a car. Because bank pay for the car price for the car. So roughly 70% of the car actually belongs to value of the car belongs to the financial company, bank. So owner, there are 3 different types of owner, even same time, bank and person and even company, manufacturer company provide their own finance program. So there are 3 at most the owner at the same time. So this is called union type. We can union to the subclass. The problem is superclass has different key attributes. Okay? For example, person is a driver license number, but bank is a bank name, company is the company name. So we can, when we inherit to this one, driver license number plus the bank name plus the company name, no, that doesn't make sense anything. So instead, you can create another key ID, key attribute in addition, like the owner ID. Okay, so owner ID, then each one can use that owner ID. Okay, so that is the union type. It's a type of the entity owner. It's a similarly the registered vehicle. So we can use the U instead of the T or O to represent the union type. We will see one more time this union type, how we can build the relational database for union type later. Okay? So this is the example of the EER diagram. Also you can see the handout, the same picture for universities. Okay? At this time, definitely it has many entities, also many relationships over here. I believe that in your homework you draw the ER diagram for bank database, right? So that's the same thing. You get any types of database or the data domain that you are going to model. It's the same process. Identify the entity, identify the relationship, identify the attribute, and if there is a weak entity, you can find the weak entity, and so on. Also, if you have the more details of the relationship, like the super and subclasses, you can use the EER concept for the conceptual modeling. That's the end of the conceptual modeling. One more time. Understanding the concept of EER modeling is not very difficult. Everybody can understand. But the problem is whether you have the experience. Sometimes there is no general answer. That's the problem. When I make the question for your midterm or final exam, so somebody can do this way. Yes, that's true. Somebody can do this way. There is no general answer. I tried my best to make the general answer or the common answer. So, however, at the time, you should follow the requirement of the database or the data. If those requirements are not mentioned in the question or it's not mentioned by the customer, you can use your common sense or assumption. That assumption should be safe in your answer or in your report to your customer. Otherwise, if the customer does not understand what you are doing, definitely you will fail on that project. Okay? So if you can understand the meaning of this diagram, that's pretty much enough. The next step is whether you can build such a EER diagram by yourself. Okay? I'm going to skip the formal definition of the EER model, except the one thing. Finding Yes. What does the formal mean over here?
Formal mean.
Formal dress? Dresser? What does formal mean? So far we have discussed about the ER model informally. Informal means unofficial. Anyone? What does formal definition mean? Main entity?
Official.
Official? So far we learned unofficially. Subclass?
Standard.
Definition? Yes, definition of what? Formal definition. Then
Standard.
standard. So far we learned non-standard.
How to make it into that?
Efficient. So far we have learned the inefficient.
Rules set.
Formal means
Entity type.
it's not only for the ER modeling. You will see a lot of time formal definition, formal way, formal proof, formal something.
Something can accepted by all people easily, or
So which means the so far we have learned very difficult.
Standard.
Standard.
Unified.
Unified. What does that mean? Formal means mathematics.
Yes.
Okay.
Rules.
So actually computer science has been the computer science comes from the mathematics, part of the mathematics. Okay? Then it focuses on the computerized system and computerized algorithm and so on. Last year, when we, for example, the database, so when we define something like the entity, how can I explain the entity? Entity is something existing things. Do I explain? It's a perfect? No, it's an informal way. I just describe, I just mention. Actually, it's not perfect. But for your better understanding, I explain the description of the definition. That should be actually defined using mathematical terms or mathematical way and mathematical equation, mathematical definition. That is formal. Okay? Very important. So when you are doing the research, so I have a new idea to manage the database. If I use this idea, we will get the 10% increase when we access the data. At that time, how can you prove your idea? You should prove your idea to others. You should appreciate. How can you do that? Analyze. How to analyze? Analyze what? You need to prove your idea, right? How can you prove it? Using mathematics. You don't have to implement. No, it's a waste of your time. If you can prove by the equation, like the efficiency of the mine is better than efficiency of the previous, if you can prove that this one, that's it. You don't have to worry about the computer language. No. Mathematical way is the perfect and best way in the research. Physics, yes. Geology, yes. Any research, if you can prove the hypothesis. First, when you are doing the research, first thing you need to do is the hypothesis, right? Build the hypothesis. If I use the set theory to manage the database, it will provide a 10% increase in efficiency, in terms of efficiency. That's the hypothesis. You need to prove. How can you prove? Mathematics. That is a formal way. However, especially in computer science, it's not always possible to prove the idea or algorithm formal way. At that time, there are a bunch of different way, alternative way. What can be the other solution? PhD student. Any PhD? How can you do research? How can you prove your idea in your research? Simulation is one of them. You can use a simulator like the NS2 in networks. Network, do I need to build all the networks? It will forever, and you don't have enough money to build the network infrastructure. Instead, you can prove your idea by simulation. Also,
Mathematical model.
we already talked. Sometimes mathematical model is not acceptable, not very difficult. Or you can implement, directly implement. I cannot prove my idea, but you can build the relational database model. Okay? Sometimes you can build the entire system, sometimes not. I think if you already took the operating system, you learned in your operating system class to prove the algorithm. Okay? There are different ways. Okay? So, formal means it's a mathematical way, but I'm going to skip this part. It's your work by yourself. Okay? You can see some the mathematical notation for formal definition. Also, we can use some alternative diagrammatic notation like the UML or some others. Even we are using the Crowfoot notation in the diagram. Even for the diagram, there are a bunch of different ways. We use the Crowfoot notation in our exercise lab. Our GA will explain a little bit more about this. Okay, so this is the end of the chapter 8. I have the homework for you, 8.17. Exercise 8.17. That is the extension of your first homework, 7.21, bank database. You can extend your bank database to EER model. So if you successfully done for the previous homework assignment, I think you can easily do the next one. From now on, I cannot guarantee to provide the scan question, okay? Because it's your responsibility to possess, to keep the textbook, okay? Please do not email me even though I do not provide the copy of the question, okay? But I will try to my best, but please do not email me, okay? It's my option, okay? So if you or attitude is very well, I will. Anyway, so this is the question for it's the same thing. I will allow only the handwriting, do not copy, do not paste, draw the EER diagram at this time. That's being allowed, okay? Any questions so far? If not, I'm going to ask a question for you. Mohammed Mahdi? Yes. So far, what did we do so far?
What
did we do in this class?
Yes, we understood the EER model.
So we learned the EER model, right? For what? Why do we learn the EER model?
Analyze the data.
Analyze the data?
Database.
Design. So we design for what? Design the database.
Yeah.
Database. Our goal is the design. What's the title of this course? It's a designing, right? Designing database. So eventually, we will build a database. The first step of building the database is the designing. Okay? From where? Using what?
We have the requirements.
We have the requirement of the real information, real life information. Sometimes your customer will provide such a requirement, sometimes not. Okay? So anyway, so we are going to design such information to the database. Do you use any specific model or concept tool? That is a ER or ER model. There are a bunch of other modeling techniques, okay, such as the UML model you can use, or sometimes network model, sometimes a hierarchical model, which we are not going to cover in this class. We select the ER model. First step is from the information. It's just the first step, organized using entity relationship. Okay, so we can get the very nice ER diagram. Then computer can understand a little bit. Not it's still far. Computer actually cannot understand such a diagram. Even though you are using the tool, even though you are using the very fancy, nice drawing, computer cannot understand. Human being can understand. It's not just conceptual level. It's not physical implementation. It's just conceptual model. However, using that ER diagram, we can easily move to the database model. It's one more step further. So we need one more data structure that close to the computer. Okay, that is called database model. Okay, if you use such an ER diagram to your programming, that is something programming model, programming architecture. But we are going to build a database. So we need something database model, which is relational database model. Just like the conceptual model, in the database model, there are a bunch of other things. Okay? So, one of the examples of the other database model is hierarchical database model. In hierarchical database model, the database, even this hierarchical database management system, HDB, sometimes it's called the HDB, manage the data, okay? And also it provides the query, access the data. For example, we have the banking database. Banking database so first time when we build a banking database, you say, what is a hierarchy? Did you take the algorithm course? Yes, I think so. That's another requirement for computer science. So, manner? Yes. What is the hierarchy?
It's the level from the level of...
You forget my tip. Hierarchical, what is a hierarchy? Most of my question can be answered by what? Data structure. It's a data structure. Okay? So what is a hierarchy? Data structure. But definitely different from others. What is the characteristic of the hierarchy data structure? Let me change the question. What is the similar data structure as the hierarchy? Tree and graph. Okay? Especially tree. Okay? So, what is the difference between the tree structure and the graph structure? Why don't you think about it? This is not the algorithm course. Probably I need 30 more minutes to explain that. So, hierarchy has parents and children relationship. So, for example, we have the bank. Bank has what? Branch. 1, 2, and branch 3. Sometimes the supporting department. Department has HR and the payroll and so on. Branch has manager, customer, and the staff, whatever. And customer has account. Okay? Saving account and loan account. Saving account, it has some different MMDA, and whatever, and so on. This branch has the same structure as this one. So when you access the data using the hierarchical database, first go to the bank, then branch 1. Branch 1, customer, and customer, the saving account, MMDA account. Then you can finally get the data. Okay, very fast, really fast. What you need to do is, so you need the operation like the get next, for example, get unique. In this case, get unique. You can get the unique data from here, the branch ID. Then using the branch ID, type of the person, so second, and for this one, you can get the next level data very, very fast. The problem of this kind of the management is what?